So in today's lesson, we're going to be talking about how to get a linear equation from a description. So you may remember that in yesterday's class, what we did was we were able to get a linear equation by looking at the graph of the relationship, right? I can see this is a linear relationship, and if I see that it's linear, then I can create an equation in the form y equals mx plus b by knowing the slope, the value of the slope, and the y-intercept. Right? We also talked about how, I don't want to necessarily use x and y. I maybe want to use variables that will help me to remember what's going on in the situation. So for example, here on my vertical or my y-axis, I'm using costs. So you may wish to replace the variable y with the c. Also, instead of the variable x, for my horizontal axis, I might want to choose number of kilometers. So maybe I'm going to just choose, D for distance, or K for kilometers, or N for the number of them, right? So, and we were able to get all the other values from looking at my y-intercept and my slope. So in this case, my y-intercept is a 30. So I'm going to go ahead and replace the value of b with that 30. And my slope I can get by looking at my rise and my run. So for instance, when I pick this point right here and I pick this other point right here, I can quickly grab the slope off of that. We're going to pretend that's a straight line. My rise is 3 squares, but since each square represents 10 units, my rise is 30. And on my horizontal axis, each square is representing 10 units, but I have 4 squares, so that gives me 40. So 30 divided by 40 will give me my value for slope. And since it's a real-life situation, I want to put a decimal. So 30 divided by 40, perfectly acceptable to put a decimal there. And so I'm going to do that. 30 divided by 40 is 0.75. Here we go. Right? So another thing that's really important to remember is that those values for slope and for intercept have meaning, right? So in previous lessons, we've looked at trying to interpret the meaning of the slope and the intercept in order to, figure out what's going on in the graph. Today we're going to take information, right, the meaning of stuff, and then turn it into an equation. So like for instance, this 30 here, well, what does that mean? It means that the starting cost was 30, right? This looks like maybe it's somebody who rented a vehicle and they paid $30 at 0 kilometers, so flat fee at the beginning. And then for every kilometer they went extra, then they paid a certain amount of money. That slope tells me that the amount of money that they paid was 75 cents a kilometer. And I can figure that out very quickly by saying, well, my slope is equal to my rise over run. Rise is, the units here are dollars, dollars, and I'm going to say per kilometer. The kilometers on my y-axis. My run is my x-axis rather, and so it's dollars per kilometer. That's what this 0.75 is representing, right? 0.75. Right, so there I go with that. So the reason that I wanted to remind you about the fact that the slope and the y-intercept have meaning is because we're going to have to understand information in a description, and that will tell us which part of that description relates to the slope and which part relates to the y-intercept. So your clues or your cues within the description to tell you what the slope is you're looking for something that's a rate. Okay, because slope really represents the rate of change, right? So you're looking for something that is a rate. Whereas the y-intercept basically gives information about the starting point for a situation, right? So we call that an initial value. So those are some clues that you'll be looking for in a description to help you figure out what part represents the slope and what part represents the y-intercept, so that you can eventually plug them into a linear equation in slope-intercept form. So before we begin, I want to go over some key vocabulary, some key words that will help you to identify what the rate is, because remember that the rate is really just, you know, that's your slope. And the initial value is really your y-intercept, right? So, all right. So keywords for rate. Well, you know, when you think about rate, what do you think about? I think about dollars per hour, right? So, or I think about kilometers per hour or something. So I'm going to be looking at something that's per something else, right? Another thing is I might say, you know, it costs $3 for every pound, right? So I might see something for every something, right? I might see that it, sometimes when we're talking about, you know, the wages that you make when you work at a job, you might be saying I make, you know, $20 an hour. So it might be blah, 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 on blah, 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 right? Or and whatever. I think that's a good start. Now when we talk about initial value, right, so the y-intercept, the meaning of the y-intercept, we can talk about, say for instance, you know, starts at, right? We can talk about flat fee, right? Maybe there's a flat fee for something that doesn't get affected by any other factor in the situation, right? You can say that initially at, or something like that. So those are some good words to look for to help you decide if the information that you're looking at is, you know, the slope versus the y-intercept. All right, so I think we're ready to at least start to discuss an example. I'm going to lead you through this one pretty well, just to help you out with it. So when I look at a question, I want to read it all, and sometimes if I'm not fully getting it, I want to read it again. It's just kind of a good way to go about things. And I often use a highlighter to help me highlight what I think is important information within a question, right? So in example 1, it says a taxi driver charges a flat fee of $2 plus $1.50 per kilometer, right? So I'm going to highlight some of these important parts. So flat fee of $2, right? And then $1.50 per kilometer. So those to me seem like important things to be looking at. So the next part says identify the initial value and the rate of change. So I'm going to go back and I'm going to read the equation, the information at the beginning, the description. A taxi driver charges a flat fee of $2 plus $1.50 per kilometer. All right, so if I'm asked the initial value, so we spoke earlier about initial value, that means kind of like a starting point, right? And one of the words that we looked at was flat fee. So the initial value is really my y-intercept. And in my opinion, the initial value is that flat fee, right? And so that means that before I even drive anywhere, this taxi driver is going to be charging me $2. And so now I want to know the rate of change. And so in this question, what tells me that piece of information is in fact a rate is the fact that I see this per, right? So I know my slope, the thing that's changing with every kilometer that I move, is the $1.50. So I'm going to put 1.50. So there's my slope and my intercept. Now, write a linear equation to represent this situation. And so I'm looking at the cost of a cab ride. So I'm going to say that C is the cost. Okay, the total cost. And I'm going to also say that my other variable is kilometers. I'm going to use the variable d in this case to represent the distance, right? But I could have chosen other variables that made sense in the situation. I just happened to choose these. So here's distance. So you'll remember that I'm going to write this in slope-intercept form. And so I really need, I know my cost is going to be equal to something my slope multiplied by my other variable distance plus the value of my y-intercept in this case, right? Really, if I think about it, it's actually my c-intercept because c is replacing y in the equation. So I've figured out what these variables are. So my variable or my value rather, for slope is 1.50. So my equation starts out at being c is equal to 1.50 times d plus 2. And let's look at that equation to make sense of it, right? I know I'm going to pay $1.50 per kilometer, right? So depending on the kilometers I actually drove, I would multiply that by the $1.50, right? So for instance, if I drove 2 kilometers, I know 2 kilometers times $1.50 is going to give me $3. But then I need to add on that flat fee of $2. Moving right along. So now I'm going to use my equation, the one that I just created, that's this guy right here, and I'm going to help it to allow me to determine the cost of a kilometer ride, a cab ride that's 12.8 kilometers. All right, so I'm going to just get rid of some of this information and move my graph up so I can, my information up so that I can show you this a little bit better. All right, so if I want to figure out the cost for 12.8 kilometers of a cab ride, I'm going to use my equation. So I may not need to use the equation, but you know, if the question asks you to specifically use the equation, then you want to make sure that you're doing that. But what information do they give me? Well, they give me the 12.8 kilometers. That just happens to be my distance, right? So I'm going to substitute or plug in 12.8 wherever I see the d in the equation. So I'm going to put whatever d is right here into this spot, because remember that variables beside values, that implies multiplication. So I'm going to put in my 12.8 here. And BEDMAS tells me that I need to multiply before I add. And so when I work that out, again, I'm going to do the 1.50 times 12.8. And that's going to give me 19.2. So far I'm at 19.2, but I'm not done yet because I still, so that would really, what does that really mean? That means it's $19.20 just for the 12.8 kilometers. But then at the end, I need to tack on that extra $2 charge, right? So 19, 20, 21. So it's really, the cost is going to be $21.20, and that does not include a tip. So that is how I want to go about solving questions that ask me to create an equation from the description and then use that equation that I've developed to solve problems. So this is the first of 2 videos. This is where this video is going to end, but if you feel like you need greater reinforcement with this, there is a second video. I'd encourage you, if you're struggling, to watch that video as well with a couple of more examples just to get you better used to these concepts.